My presentation today is focused on the operation side of things. My division in physical plant operates utilities and is responsible for energy conservation programs and carbon reduction initiatives in the operation of those utilities and buildings and the heating and cooling and so on and so forth of the building. So that's the focus. So I put together a slide deck to everybody can see it, right? Did I share my screen correctly? And now it's not moving. Oh, there we go. Okay, so we use a lot of energy at Penn State, in the dorms, in the dining halls, in our classrooms as part of instruction, at our athletic events, and in our labs. Our labs just use a tremendous amount of energy with research, the fume hoods, the outside air and ventilation needs of research and of lab spaces. Every year, our campus uses the same amount of energy as a Pennsylvania city of 30,000 homes. So anybody care to guess what our heating, basically our gas bill and our electric bill is every year at University Park? How many zeros? That's pretty big. Our electric bill is about $16 million a year, and our gas bill is about $7 million a year, and it varies depending on the year and the cost of the commodity, but that's in the ballpark. So the next three slides are just 30 seconds on Utility Systems 101. So I wanted to talk just real quick about the way we heat campus. We have two steam plants, one over on Porter Road and one down at the corner of Burroughs and College. We call the West Campus Steam Plant. They're interconnected by an underground network of steam piping, which delivers steam to the various buildings, and most buildings converts the steam to hot water and either uses to heat the buildings or make hot water for showers and for use in the dining halls and dishwashers and things like that. Both these plants now use natural gas. The West Campus Steam Plant used to use coal, and we converted that a number of years ago. We have a combustion turbine at the East Plant that makes electricity on site and uses the waste heat to generate more steam to heat the campus, which is a very efficient process. And we're going to put another combustion turbine at the West Plant. So the project's underway, and you'll hear more about that later. Moving on to cooling, we have a central chilled water system that serves over 100 buildings on campus, shown in blue on the diagram there. We have 3 plants that generate the chilled water, that pump the chilled water to the various buildings for cooling. And the last utility slide has to do with electric. We generate about 20% of our electricity on campus. What we don't generate, we buy off the grid. It's that power is delivered to 4 locations through 10 circuits, as the 4 locations are shown on the stars. The orange lines are overhead distribution, and the yellow is underground distribution that moves the electricity around to where it's needed on campus. All right, so turning to our greenhouse gas inventory. So the inventory that we keep includes direct emissions and then emissions from a couple of things: purchased electricity and commuters, namely. And if you look at the pie chart on the left, you can see that we've broken it down by sector. And if you add the blue, which is the dark blue, which is purchased electricity, the red, which is the steam plant, and the lime green, which is stationary sources like buildings with happen to have boilers in them or separate chillers, they make up 75% of Penn State's greenhouse gas emissions, just energy. The other big light blue wedge our commuters. And so there's a allowance in there. It's a pretty soft number, but there's an allowance in there for employees to drive to work and students. And some of the campuses are very heavy commuters, so those campuses have a bigger commuter footprint than others that might have mostly residential, housing for students. On the right, the pie chart breaks it down by campus, and you can see that University Park is by far the campus with the largest footprint. All right, so prior to 2005, our Penn State was growing and our greenhouse gas emissions were going up. And then way back in 2005, we started working on some programs. What would we do? And we set some goals. Our first goal was a 17.5% reduction by 2012. And then we looked at our buildings and we said, all right, we're going to reduce the energy density or energy per square foot by 20% over 10 years by 2023. And then we set a long-term aspirational goal of an 85% reduction by 2050. Now remember, this was in 2005. So today you could probably argue that it's not good enough. We've carried this goal all along, because it really doesn't change the way my department looks at this. If we can get to zero quicker, we will. But that was our goal that we started this whole program with back in 2005. And what an 85% reduction means is we're going to take that wedge on the left and we have to cut it all the way down in size to the one on the right. Basically, you have to get rid of the steam plant emissions and all purchased electricity in order to, and we're in discussions now on whether or not it should be net negative and how would we get there. So, all right, so what have we been doing in the last 15 years since we started this? So when we renovate buildings and build additions or new buildings, we've tried to set good design and construction standards, so we build them right the first time around and don't have to go back and retrofit them. And that's really hard, but we're doing, we've upgraded our standards. Second bullet there, we have an energy conservation program where we have $12 million a year that we invest in energy conservation projects. Those projects have to have a payback. They have to reduce our energy use, and the savings is used to pay back. It's basically a loan. Central administration gives us a loan and we have to pay it back with interest out of the energy savings for the projects. And those projects can vary from envelope improvements to new HVAC systems to better lighting like LED, just all kinds of things. And the two photographs on the bottom are visual examples of a project we did at Bryce Jordan Center. You can see on the left, the yellow, there was a lot of leakage, a lot of infiltration occurring there. We did a $600,000 project to tighten that up, and you can see the photograph on the left, the infiltration is gone. Another program is our commissioning program. This was highlighted. I noticed that Mark sent you the link to the NPR article that got done a while ago, and that was talked about at length in the NPR feature. The commissioning program tunes up existing buildings, and it does it. It has several goals. It tries to make the most efficient building and most comfortable building for learning and research, but it also then tries to lower its energy use while doing so. And that's one of our better programs. We consistently get 5-year paybacks out of that effort, tuning up buildings. And then the last big heading is our utility system upgrades to make our utility systems on campus more efficient. I mentioned earlier that we make about 20% of our electricity already on site, and one of those devices is is pictured on the right there. It's a combustion turbine that uses natural gas to make electricity, and then it uses the waste heat in the flue gases to capture that energy and then make steam out of it. So it's a really efficient process. Yeah, it still uses natural gas, but it's very efficient. It's a low carbon, considered a low carbon approach. And we're in the process of putting another one of these at West to improve the efficiency of the West plant. I mentioned earlier too, we converted the West plant from burning coal to burning gas. That was a 3-year project, and we burned our last lump of coal in April of 2016. All right, so all along the way here, even back in 2005, we quickly thought of renewable sources, and everything was very expensive back then. And our goals is not to increase Penn State's costs to go green. We attempt to try to do things in a way that don't increase costs, don't increase tuition. In other words, switching to a renewable source for electricity, it's got to match what we're paying for fossil fuels or do better. And we could see this cost of solar coming down rapidly for many years. So we started to get ready. Where would we put solar on this campus? So we did a study that looked at ground mount locations and roof mount locations and over which parking areas. And it was a pretty interesting study. You know, roof mount locations, our older buildings couldn't support the added weight. So you'd have to do, you know, structural reinforcing of those roofs, which cost a lot of money and drove the cost of a roof mount installation up. Same way in parking areas, to build the structure, to get it high enough so that we could still run plows underneath it, and areas closer to the stadium that are tailgating, you need to get, you know, Winnebagos underneath them, and a lot of times you have to move the islands, you have to replicate the lighting system, you have to put new lights underneath. You start adding all this together, and the over parking areas was one of the most expensive ways of adding solar to campus. But a couple of ground mount locations, one in particular would look pretty good. And although it wasn't that break even that we were looking for, it wasn't bad. It was $60,000 a year more. So we convinced President Barron to let us go ahead, and he found the extra money that we needed. And we went ahead, and it's the project that's along Orchard Road by the hospital. Many of you probably have seen it driving by. This was an early sketch of what we thought we might do. And here's a better rendering of it as we started to plan it a little bit better, and where it would locate and how much it would, how big it would be. And this is a shot of it during construction, just to give you some scale. Here's a picture of one of OPP's student interns that was on site, so you could see how high. Now these are fixed panels, these aren't tracking ones. And then here's a drone shot of the finished product. And so back in the day when we were working on this, we were starting to realize how much land it's going to need to install enough solar to offset University Park's annual electric use. So I wanted to ask you guys, what do you think? You know, we purchase, this slide's a little old, so it's a little less than 290 million kilowatt hours a year that we purchase off the grid. But how much do you think it would cost, and how much area do you think you might need to deliver all University Park's electric generation from a solar source? Probably no idea, because I wouldn't even
how many football fields?
Oh yeah, it's amazing. We need 1,000 acres. I mean, it's probably a little less than this now, because this is an older slide and the technology is getting better and they have tracking installations. So this is several years old, but an $800 million it would cost. And how big is that? Well, it's the whole campus. We do not have, this is 1,100 acres, and we just don't have the land. So we knew at that point we needed to go off-site. So a couple of years ago, we we put together an RFP and we teamed up with a solar developer, and we did a project that you've probably heard about in southern Pennsylvania in Franklin County. 25, it's going to provide 25% of our statewide electric use. We have a 25-year agreement. We started taking power off the project on October 1st. And there are 3 sites in the same county, in Franklin County, 3 large sites totaling approximately 500 acres of solar panels. We did well. We actually are bringing this in at under what we're paying for electricity off the grid. The first year savings before the pandemic was expected to be $250,000. Now, I haven't looked with the electric use down everywhere because of the pandemic. Electric prices have dropped even lower. So it's very possible we entered into a contract where we won't realize the $250,000 savings because we're obligated to pay what we negotiated with Lightsource BP, and we could probably buy it cheaper now off the grid since the pandemic. But I haven't looked at that. So here's an aerial drone shot of one of the 3 sites. And you can see how far into the distance the solar panels stretch. So these are pretty big sites. We also purchased entered into what's called a power purchase agreement from a hydro site in western Pennsylvania. So about 9% of our electricity comes from this hydro project. What else are we doing? We're increasing our OPP fleet in electric vehicles with these Nissan Leafs. We built a small array in front of the building that can ultimately offset the energy use of about 30 electric vehicles. I think we're up to 8 now that we've purchased. And we built the array with students, which was really cool. All right, so here's some trends. Here's how we're doing. So this slide, this is at University Park alone. This is not Penn State wide, just UP. And this is total energy. It takes natural gas and converts it and electricity and converts it to the same units, MMBTUs. And you can see here that we're using the same energy, total energy at University Park now than as we did back in 1995. And we've got about 8 million more facilities on this campus than we did in 1995. If you look at our greenhouse gas emissions, the red line is the graph of the greenhouse gas emissions, and we've dropped our greenhouse gas emissions to pre-1975 levels now, and we've got 9 million more square feet than we did back in 1975. Okay, so this graph shifts back to Penn State wide. This is a sum up, and it shows there's a lot of going on in this. Is kind of a busy slide. Sorry about that, but so this shows prior to 2005 our emissions. This, everybody can see my cursor. Okay, good. This shows the reductions. This here is our first goal, which was the 17.5% reduction by 2012, which we hit. Our second goal right now is a 35% reduction, and with the solar project, we're on track to hit it. And this is what I mentioned before is our aspirational goal, our 2050 goal. Now, what you can do is look in the vertical bars here. These colors mean are tied to different sectors. So you can see that if you look at the purchased electricity, you can see it getting, you can see it getting smaller and smaller. And you can see a big drop when we have next year when we have a full year of the solar project down in Franklin County. You can see the footprint of our electric purchases getting smaller. And if you look at the red is from our University Park steam plant, and you can see it also getting smaller as we do different projects, as you know, as we convert it from coal to gas, and then as we add the combustion turbines, and as we do other efficiency projects in that utility. And then if we just drew a straight line just to give us some targets, again, based on this 1990, 80% below 1990 by 2050, which probably isn't a steep enough curve, but it just gave us some targets to hit along the way, of a 2030 goal of around 50% and a 2040 goal of 70%. And nowadays, the decisions that we are making today in facilities will still be around in 2050, because facility HVAC systems and utility systems last that long. So we're making long-term, and it's really hard to make good decisions as far as, and I talk a little bit more about why that's so hard here coming up. This slide shows the various strategies. So across the top of this colored wedge slide is where we think we would have been greenhouse gas emission wise had we not done anything. This solid blue line shows from 2005, it shows how the reductions tracked. And then the various colors show the different strategies. And, you know, the solar, which I just talked about, is projected on here. But what I wanted to mention, oh, and the fuel switch from coal to gas shows up here in this blue. But our workhorse is the purple, the various purple colors, which is the energy savings programs. The 12 million a year I mentioned earlier that we invest in our buildings to lower the energy use of our buildings. That's what's carrying most of the load for us in our reductions. All right, so I mentioned the additional combustion turbine, and that's going in now. It was delivered a couple of weeks ago and is being hooked up, and it should be running by, we hope, by June 16. It'll reduce our emissions by 16,000 tons a year. And I added that to the wedge chart so you can see what it's doing. It's in the clear at the bottom down here. It's in the apricot or orange color. Starts to show you the magnitude and what it does for us going forward. Oh, by the way, I meant to mention to you that, you know, the solar project over by the hospital I showed you slides of earlier. Well, it showed that project is on this chart just to show you how much solar you need to make a dent. Right there where my cursor is showing, that's the reduction in greenhouse gas emissions on a solar project that covers the whole side of the hill. It's amazing. You just need a ton of solar. All right, so we're studying the use of biomass that would displace the use of natural gas at University Park for steam generation to heat our buildings. It's got a lot of challenges. Now on the right-hand side, this graph shows that this graph is a full year, and it shows the energy use during a full year. You can see this part, energy, this is summertime, it's low. Wintertime, this is heavy winter, this is fall to the end of the year. And if you look at the different colors on the graph, we're base loading the combustion turbine at east and the turbine at west, which is this color. This biomass installation that we evaluated is colored in the turquoise, and it would eliminate natural gas use in all those hours for a whole year. But anything above that steaming capacity, the whole green, we would still use natural gas. Well, the project to wipe that out is $100 million first cost, plus the biomass costs more than the fuel cost is higher than natural gas. In the wintertime, we'd be bringing in 30 trucks, big trucks, a load per day for fuel. And what has us worried is that it would consume 33% of the available biomass within a 75-mile radius. So it's already higher fuel, and what makes me nervous is if we were to do this and we put this big demand on the market, that the fuel costs are even liable to go higher. So we got high first costs, we have high fuel costs, that increases tuition costs. So this concept has a lot of challenges ahead of it. If we did do it, I threw on the graph there, you can see at the bottom, that's the size of the impact of that biomass project, what it would do to our reductions. Other things, we're evaluating some fuel cells, one at the West plant and one down at the wastewater treatment plant. We looked heavily at a biomass installation down at Penn State Harrisburg. It appears to be a really good size installation, and we got a firm quote from a company to put in to heat the entire campus with biomass. And the paybacks are pretty darn long, so we couldn't make it work. We put it on the shelf. Again, a carbon tax on natural gas use would help. Oh, by the way, what I need to point out down there is we pay more for gas down there. Biomass would be cheaper than what we pay for gas. So that project actually had a fuel savings, but the payback was very long. Something else we're keeping an eye on, the use of something called renewable natural gas. And renewable natural gas is derived from the breakdown of organic materials. And if you look at the cartoon on the right here, landfills emit methane, and farms from the manure from the animals, for example. And if you capture those emissions and clean them up, and then you could put them in the natural gas distribute. If you clean it up to pipeline standards, you can use the natural gas pipeline to deliver that to customers like Penn State. And it's considered carbon neutral. One of the problems with that is it's an immature industry right now. There's very little of it. And one vendor that we did talk to that was interested in building something for us at 7 landfills, the cost of the renewable natural gas was 5 times what we were paying for regular natural gas, which is a pretty big increase each and every year. So a lot of work to do on this, but this is a problem that needs fixed in our country, the emissions from landfills and the emissions from manure and things like that. So we've got our eye on this, and hopefully this particular industry would mature, and then the cost would come down. On a smaller scale, we're doing a couple things at Penn State. Down at our wastewater treatment plant, we do capture the biomass there that gets released, and we do use it in a hot water boiler, and we heat the digester process with it, and we heat a couple small buildings with it. And then out at the dairy barns, we just recently constructed a digester for the manure from Penn State's animal herds, and it captures the methane released and runs a small engine generator set to produce energy. And what are we continuing to do? Well, we're continuing to do the energy savings program. We're continuing to commission buildings. We're trying to get a lab banding program started. If you recall, early on in this presentation, I mentioned that labs use so much energy because of the amount of outside air they need for ventilation. Well, this would be a way of correcting that. Many of those buildings could clearly be over-ventilated for what's going on inside the labs. And this is a program that would calculate what labs are being used for activities that we can lower the amount of outside air. It's labor intensive, but it will lower energy use. So I'm trying to get that started. We have developed a rebate program for ultra low freezers. We have approximately 300 minus 80 degree Fahrenheit freezers on this campus, and we're buying more all the time and replacing old ones, and they're pretty expensive. And just like everything, you can buy a more expensive one that uses less energy, and they're typically $3,000 to $4,000 more. And OPP is providing a rebate to cover that additional cost, so we can get departments and colleges to buy the more efficient freezer. We're trying to figure out buildings that we can mothball in the summertime when the population of the campus is low. We've done a few of those last summer. We want to do more to save heating and or cooling those in the summer when they're mostly empty. And then the last thing to talk about is the 25 Live, the campus scheduling system. And some of you students may have some experience using this system, like when your clubs want to meet at night and you need a space, you can reserve it through this system. And we use that system to determine which classrooms are actually occupied and which ones are empty. And then we put the HVAC systems, they either operate to properly heat and cool the ones that are being used, or if they're empty, we put them in unoccupied to save energy. And that is now applied to 400 classrooms at University Park.